Okay, let us start. I will share the screen. Last class we did sum number 3 and left. Okay, now let us do sum number 4. I am waiting for something where you will really have some tough 11th standard level maths, but it's not coming. So far it has not come. I don't know. Only differential calculus, I think there will be some conceptual integrity, 11th standard level. Okay. Otherwise, everything will be chumma, I think. Time pass mathematics. Okay, no problem. You can time pass, get 100 out of 100. Okay. Okay, calculate the coefficient of correlation between X and Y series from the following data. Let us do that. Okay. Exercise 9.1. Fourth sum. Okay. Now what is given? N is given. N is given as 15. Number of pairs of observation given as 15. Arithmetic mean X bar is given 25. Y bar is given as 18. Then standard deviation. Sigma X is given as 3.01. Sigma Y is given as 3.03. Sum of squares of deviation from arithmetic mean. Correct. Summation of product deviations X and Y series from their respective arithmetic mean. That is equal to 122 is given. Summation of the product deviations of X and Y series from the 122. Okay, that is then sum of squares of deviation. Okay, sum of squares of deviation from the arithmetic mean 136. Then sigma dy squared. That's given as 138. Okay, all this is given. What is asking to find? Calculate correlation of coefficient. Actually, this all not so many things not needed. Correlation of coefficient. You remember? Let us take the first. This one you take. What is the first formula? Covariance of x comma y by sigma x into sigma y. Okay, where the covariance of x comma y is equal to 1 by n into sigma x minus x bar by y minus y bar. That's all. Okay. Sigma x minus x bar into y minus y bar is 122. N is given as 15. This one you need, this one you need. Okay. Then by sigma x and sigma y into sigma x into sigma y. This one is given, this one is given. All this not needed, this not needed, this not needed, this not needed, this not needed. Okay, that's all given just to confuse you. So that is equal to sigma x minus x bar into y minus y bar divided by sigma x into sigma y. That's all is needed. 1 by n. Correct.
Yeah.
1 by n. That's all is needed. So just apply that thing, very simple. N is 15, 1 by 15 into how much? Sigma x and already 122 it is given, divided by sigma x is 3.01, sigma y is 3.03. That's all. So calculate 122 by 15, how much? What all they are trying to confuse you? See, 133 divided by how much is 3.01 into 3.03? Okay, now 8.123, 8.133 divided by 9.12. That is equal to 0. Plus 0.89. 1 you can drop off. That's all answer. So R is equal to positively related, very high correlation coefficient, because almost 0.9 it is coming. Okay, that's all you need to do. These fellows are giving this data, that data, all kinds of data in order to confuse you. Okay, it's a simple formula you take and you do that. That is the fourth sum. The fourth sum is finished. Okay. Okay. Now let us post this in your WhatsApp. Now fifth sum and sixth sum you should do, because there are no tricks, nothing. No tricks, nothing. Okay.
Okay.
So you can directly do fifth sum and sixth sum. Let us do seventh sum. If some meticulous calculation you should do. Okay, your homework you do. Sixth sum also homework you do. Now fifth sum, if you take mean, it will coming 31, like that it is coming. Okay, so that means mean is a whole number, integer it is coming. So you don't need to use assumed mean method. You use mean method itself. What is mean method formula? Sigma x y divided by root of sigma x squared into root of sigma y squared. Okay, that is a formula you should use. Okay, assumed mean method you use for sixth sum, because y x is coming whole number, but y is coming as 90.5.
Yeah.
Why? Okay, so I tried that. No, so sixth sum you should use assumed mean method.
Okay.
For that you have to use sigma dy dx, sigma dx dy, n into sigma dx dy. That formula.
And then n root of dx square minus dx
So
square.
tell me n into
n sigma dx dy minus sigma dx dy, and then by n root n sigma dx square minus sigma dx square into root sigma dy square sigma dy square minus sigma dy square. Minus sigma dy square, uncle.
very good. Very good, boss. This formula is assumed mean method. Okay, this you use for sixth sum. Fifth sum, don't use that method. Use direct mean method.
Okay.
Which is sigma xy divided by sigma x squared into sigma y squared, where x is equal to x minus x bar, y is equal to y minus y bar, like that. That's all. That sum is which one? Example sum they did like that. I'll tell you which example sum. Okay. Example 9.3 you use for sixth sum. Okay. Example 9.1, first sum. That one is like for fifth sum.
Okay.
Okay, you follow that model. Okay. Now let us go to seventh sum. because it will take a lot of time and we will not be learning anything new because we already solved the example. Seventh sum. Okay. Examination of 11 applicants for an accountant post was taken by a finance company. So our company is giving applications for taking applications for accountant post, and then they give some entrance exam. Marks obtained by the applicants in the reasoning and aptitude test are given below. Okay, A B C D E F G H I J K 1 2 3 4 5 6 7 8 9 10 11 fellows. So n is equal to 11. 11 fellows are there. Huh? So what you have to do? Reasoning test and aptitude test. Okay, let us take reasoning test is, sorry. This is reasoning test. That is aptitude test. So fellow got 20 marks, other fellow got 30 marks in the other exam. Then he got 30 marks and 60 marks, another fellow. Third fellow got 28 marks and 50 marks. Fourth fellow got 25 and 40. Fifth fellow got 70 and 85. Then the other fellow got 90 and 90. Then 76 and 56. Then 45 and 82. 45 and 82. Then 30 and 42. Then 19 and 31. Then 26 and 49. This fellow got. Okay. Who is the first rank you have to put? Rank of X you have to put here. And then rank of Y you have to put here. Okay. Rank of Y. Then rank of X minus rank of Y is equal to D. That you have to put here. Then D squared you have to put here. Then you have to get sigma D squared. You have to get here. Okay. Sigma D squared. After that, what you have to do? Rho is equal to Spearman's coefficient is equal to 1 minus 6 into sigma di squared divided by n into n squared minus 1. Okay, that form I have to. N is 11. That is equal to 1 minus 6 into 11 into 121 minus 1. Okay, let us see. Okay, rank 20, 30, 28. Which is the lowest rank? This one, no? 1, first rank. Next one, 20, second rank. You tell me what is third rank? 25? Okay, 25, third rank. 28 is fourth rank. 30 is fifth rank. Fellow is getting 2 times 30, huh?
Yeah, okay.
Times he's getting 30th rank. No. 30 and 42. Something wrong I entered. 20, 50 and 60.
50, okay.
So 30 is fifth rank. Okay, let us remove that. 1, 2, 19, 20, 28 is third rank. 28 is third rank.
Uncle, 25 is third rank, uncle.
Rank. 28 is fourth rank. No.
Okay, yeah.
30 is
30 is
fifth
fifth
rank.
rank.
And 30,
45.
45 is sixth rank. Then
50.
50 is seventh rank.
Uncle, there are 270s.
Hey, 26 you missed, man.
Oh, 26. Uncle. Okay, yeah.
26 you missed. 26 is 4th rank. 28 is 5th rank. 45 is 6th rank. 45 is 6th rank. Then 50 is 7th rank.
Uncle, 30th is 6th rank.
38 is
30 is 6th rank, Uncle.
36th rank, huh?
Yeah, 36th rank. And then 45
rank.
is 7th rank.
This is 7th rank. Then
And
this is 8th rank. 50 is 8th rank.
60 is 8th rank. Yeah. And then 70, Uncle.
70 is 9th rank.
76.
76 is 10th rank. This is 11th rank.
90
Okay,
11th
got
rank.
it. Correct. Very good. Here 30 is first rank. 31 is second rank. Correct.
Yeah.
Then
40.
40 is third rank. Then
49.
42.
Uncle, we missed 42. Yeah.
31 is there. Okay, 42 is
42.
fourth rank.
Yeah.
Okay,
And then 49.
Then
49.
fifth rank. 56 sixth rank. Huh?
Uncle, 50, Uncle.
50 is sixth rank. 56 is seventh rank.
Yeah.
60 is eighth rank.
60. Yeah.
Is eighth rank.
Ninth rank.
82 is ninth rank.
Yeah.
85 is 10th rank. 90 is 11th rank. Okay, very good. Now you got everything. Now Rx minus Ry easy. 2 minus 1, 1. 8 minus 8, 0.
0.
45 minus 6. No.
5 minus 6.
5 minus 6.
5 minus 6.
Minus 1. 3 minus 0. 9
0.
minus 1 minus 1. 11 minus 0. 3. 7 minus 2. This is 6, I think, no? Yeah,
5 minus 4.
5 are there.
6, 6, 6, 6. Yeah, 6.
Minus 4 is 2. 1 minus 2 minus 1, 4 minus 5, 1. Okay, now square that. 1, 0, 1, 0, 1, 0, 9, 4, 4, 1, 1. How much is sigma d square then? 1 plus 1, 2, 2 plus 4, 6, 10, 19, 20, 21, 22. Okay, 22. Okay, 6 into 22. 1 minus how much? 22 into 6. 12, 132. Right? 13, 130. 132 by 11 into 120. 11 into 120. 132, this will go how many times? 12 times it will go. 12 will go in this 10 times. Okay, that is equal to 1 minus 1/10. That is equal to 1 minus 0.1. That is equal to 0.9 plus R rho is equal to plus 0.9. So that means very high rank correlation coefficient between the two subjects are there, aptitude test and test. Okay, very good. So 7th problem we have finished. Let's go and do. Okay, let's do 8th problem. Let us do exercise 8th problem. We'll do. Following are ranks obtained by some students. Hey, is given rank directly. So very simple sum. Very fast we can think. So easy sum. Still okay. We started. Let us do. Commerce is X and accountancy is Y. Okay, already the ranks are given. 6, 4, 3, 4, 3, 1, 2, 7, 9, 8, 10, 5. Okay. X, Y. Y is what rank? 4th.
4, 1,
1st, 6th, 7th,
5th,
8th, then 10932. 10932. Rx minus Ry. D. Then D squared you have to. Then sigma D squared. Okay. Let us take Rx minus Ry. 6 minus 2 minus 4, 2. 4 minus 1, 3. Minus 3. Minus 6. Minus 3. Minus 1. Minus 1. Minus 1. 7. 3. Okay. Then square it. 4, 9, 9, 36, 9, 1, 1, 1, 49, and 9. Okay. So how much is 4? 9 plus 9, 18. 19, 20, 21, 30, 36, 45, 54, 55, 57, 58. 5 plus 3, 8. 8 plus 4, 12, 128 is coming. Okay. Now you calculate rho is actually 1 minus 6 into 128 divided by how many is n? N is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is equal to 10. Okay, that means 10 into 10 squared minus 1. That is equal to 1 minus 128 into 6, how much? 48. 2, 6 are 12, that is 16. 1, 6, 768. Okay, okay, 768 divided by 10 into 100 minus 1 is 99. Okay, that is equal to 1 minus 768 by 990. Calculate 768 by 990. How much? Correct, huh? Coming, huh?
Yeah. .224.
Correct. So there is a slight positive correlation. If this increases, that also increases. Okay. In commerce and accounts, slight, they're not very heavy. Okay, 0.9 it comes means it's very heavy. Okay. So 8 sum also over. Let us post it now. Very simple sum, no? Last sum was tougher. Why they give the tough sum with the first and put easier sum next, I don't know. Okay, anyway, it's easy sum, you can enjoy. I hope you are enjoying, man. The sums are all very easy. Okay.
Yeah.
It's not 11th standard maths. It's actually 6th standard, 7th standard maths. Like that you're doing. Okay, enjoy. No problem. As long as we are enjoying, no problem. Okay, 9.1. Now we'll do 9 sum. Okay, let us do 9 sum. Random sample of recent repair jobs was selected. Estimated cost, actual cost. Okay, estimated cost. Now the sum is going to be long because actual numbers are given. Then the actual cost. So rank you have to do yourself now. Rank X you have to do separately. Rank Y you have to do separately. Then D is equal to rank X minus rank Y you have to do again separately. Then D squared you have to do, D squared you have to do. Okay. 300, that is 273. Then 450, 486. And 800, 734. Then 250, 297. Then 500, 631. Then 975, 872 came. 475, 396 it came. Okay. 400 it came to 457. Okay, let's start ranking. Which one is smallest? 250. One. Then 300 is 2. Then
400.
400. Okay, 3. Very good. 450 is 4.
Yeah.
500 is 5.
475
is 5. 500 is 6. Very good, very good. Got sharp eyes. Then 6 is 500. Then what? 800. Then 975. 1, 2, 3, 4, 5, 6, 7, 8. So n is equal to 8. Very simple. So you can see rho is equal to 1 minus 8 into whatever divided by 8 into 8 squared minus 1. Correct? Sorry, 6 into. Okay, let us keep it like that. Okay, RY first rank, which one? Smallest is first one only, no?
Yeah, first one.
First one, 297, second one?
Second one, yeah, 297.
396. What is that? 396, third one?
Okay. 457.
Okay, then?
486.
486. 500, anything is there?
No. 631.
Okay, 6. Then 7.
734. 872.
Okay, 8 ranks you got. Okay, very good. Okay, Rx minus Ry, very simple. 2 minus 1, 1, minus 1, 0, minus 1. This is 5 minus 6, no? Minus 1. 0, 2, minus 1. Okay. 1, 1, 0, 1, 1, 0, 4, 1. Okay, so sigma d squared is equal to how much? 5, 6, 7, 8, 9. Oh, that's all, huh? Very good, yeah. Very simple. This is all mental sum it is becoming. 8 standard, 6 standard like that. 54 by 8 into 64 minus 1. Correct? That is equal to 1 minus 54 by 8 into 63. It will go 9 times. 9 will go. 9 will go. 9 go. 9 goes 6 times. 9 goes 7 times. That is equal to 1 minus 6 by 56. Again, you can cancel 3 by 28. 1 minus 3 by 28. How much is 3 by 28?
0.107.
107. Okay. So our final answer row is okay. That is the final answer. Very easy sum. 0.892. Which sum is this? 9 sum, no? Something mistake, I think, in the calculation. 1 minute. Sigma d squared they are telling is 9. 4 plus 1, 5, 6, 7, 8, 9 only it is coming. Also this color is coming 5, 6, 7, 8. 1, 1, 0, 1. Hey, this one is 6, man. This one also 6. Okay. Not 5. So this is 0, this is 0, this is 8. That's what I'm thinking. This is also 8. Okay. That means this whole thing we have to change now. This is the problem. The eraser doesn't work well here. Big problem with this thing.
Okay, I might need to drag it. Yeah. No, uncle, you need to like drag it the circle thing. No, uncle, like the yeah.
One by one, you have to make it erase. Yeah, that's the problem.
You can make the the square bigger, uncle. If you click it
Huh?
and then drag it.
That's I'm not able to do. It's not allowing.
Oh, okay.
We do like that. It's not allowing.
Uncle, try using a mouse and then do it instead of the pen.
I'm doing it with the mouse only.
Okay.
Now it is coming. Okay, no problem now. Let's do 6 into 8 by 8 into 64 minus 1. 8, that is equal to 6 by 63. That is equal to 3. It goes by 3. 3 times it goes. This goes 21. 2 by 21. 1 minus 2 by 21. So you have to change the answer. How much is 2 divided by 21? 1 minus 0.095. So answer is 0.905. 1 minus 0.09. Yeah, correct. Okay. You have to be very careful with the small calculations. One small calculation, we did a mistake. See, so much time it is taking to rectify it. So that's why you must be very, do slowly, but do it correctly. Okay. What sum was this? 9 sum? Okay, let us do 10 sum now.
I think this was 8.
No, 9 sum. 8 is only directly ranks, already done.
Yeah.
With this one, we should finish that and move to regression analysis. At least 20 minutes, I want to do regression analysis so that next week we can start 9.2 exercise. Examples, at least we can start doing next week. Okay, 10. Rank of 10 students of batch. Oh, rank is given. So very simple. Rx, Ry already given. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's given like that. Then 6, 7, 5, 10, 3, 9, 10, 3, 9, 4, 1, 8, 2. So D is equal to Rx minus R. Then find D squared. Then sigma D squared. Very simple sums, no? Its correlation is tougher. This is very much easier. Longer, not tougher, longer. This is very much easier. 1 minus 6, how much? Now you tell me.
Minus 5.
This one?
Minus 5.
Minus 2. 4 minus 10?
Minus 6.
5 minus 3, 2. 6 minus 9, minus 3. 7 minus 4, 3. 8 minus 1, 7. 9 minus 8, 1. 10 minus 2, 8. Okay. 64, 1, 49. Then 0, 9, 0, 9, 0, 4, 36. Then 0, 4, 25, 25. Okay, 4 plus 1, 5. Plus 9, 14, plus 9, 23, plus 9, 32, 33, 34, 36, 42, 46, plus 10, 56. 5 plus 2, 7, 9, 10, 11, 12, 16, 22, 226. Okay. So rho is equal to 1 minus 6 into 226 divided by 10 into 10 squared minus 1. That is equal to 1 minus 226 into 6. How much? Yeah, 36. 2 6 are 12, 15. 2 6 are 12, 13. Okay. 1 3 5 6 by 10 into 100 minus 1. That is equal to 1 minus 1356 by how much? 10 into 199. 10 into 99, 990. So 1356 by 990, how much?
Uh, 1.3696.
1.37 you'll put. Okay.
1.37.
0 minus 0.37. So rho is negative. Negative rho is coming. See, it can be between minus 1 less than or equal to rho less than or equal to plus 1. Correct. So negative correlation. That means what it means is subject A is increasing means subject B is decreasing mark, like that. Rank. That is what it is. So we finished, man, exercise. Very nice. Very simple sums. Very simple sums. I enjoy doing this. Just simply calculation.
Yeah.
Yeah.
Very easy, no?
Very easy. Okay, let us go to regression analysis. That thing, I think that will be some more understanding, more concepts, more interesting also. Okay, let us do regression analysis now. Okay, so far we have studied correlation analysis that measures the direction and strength of the relationship between two variables. What direction, whether if this increases, that increases, or if this increases, that decreases. X increases, then Y decreases. Okay, like that. So negative and positive we found out. Direction. Then strength. How much if X is increasing, how much Y is also increasing. That also you found out. Okay. Then we can estimate or predict the value of one variable from the given value of the other variable. Okay, like that, price and supply or price and demand. Don't take price and supply. If price grows up, the demand will go down. How much if price goes up, the demand will go down, or how much if demand increases, the price goes down. Like that you can find out. Okay. Demand increases, price also increases. Let's say this is demand. If the demand increases, then the price also increases. Okay. So demand increases by 1,000, price increases by 1 rupee maybe. 1,000 more people want the same katrika, then katrika price goes up by 1 rupees. Okay. 10,000 people want more katrika, then price of katrika goes up by 10 rupees, like that. So that and all we saw. Now, new term, oh shit, I stopped the share screen. Okay. New term is coming. New term, regression. Okay. Now, don't get confused by this term regression. There is nothing. Regression means going backward. No, backsliding. In Christians will talk about backsliding. Okay, like that, going back to where? Going back to the average. Okay, that's the idea. Actually, Sir Francis Galton he only started this thing, regression. Okay, he was a biometrician. So what he found was abnormally tall people or abnormally short people, if they get married and have children, then the children tend to regress or backslide to the average population height. They go back to the average. Okay, that is what he used in order to talk about regression. But now that is not the meaning of how it is used in statistics. Okay, so don't you ever mix the term regression with the meaning of that in English. Regression has got nothing to do with regression. Okay. So then what has regression got to do? Let us see that. No, regression analysis is a mathematical measure of the average relationship between two or more variables in terms of the original units of the data. you don't understand anything from that. So let us leave the definition out and go to actual explanation. Then you will come back to the definition. You will understand something. Okay. One thing we need to understand: regression is a mathematical measure. What it is measuring? Average relationship between two or more variables. So here also it is not like normal statistics. It is like correlation only, because two or more variables, the relationship between them, it is measuring. Okay. And in terms of the original units of data, x1, x2, y1, y2, based on that only, it is measuring the relationship. Why is it different from correlation coefficient? That's what we have to see now. Okay, how is it different from correlation coefficient? Because there also between the set of x data and set of y data, you are finding that relationship. Okay, here in regression analysis, okay, two types of variables are used. Okay, that is what is missing in the correlation coefficient. In regression analysis, you call one set to say x variable or y variable. Okay, one variable is the value to be predicted. Is called the dependent variable. Okay, and the other variable is used for prediction is called the independent variable. Okay, suppose let us say the temperature of the sun is taken as a y variable. Temperature of the sun increases by 10 degree. Okay, then x variable is the number of people die with sunstroke. Okay, or number of people faint with sunstroke. That is x variable. So if y variable increases, then the number of people would fall down and or die with sunstroke also increases. X also increases. So x is dependent on y. You understand? Number of people who die of sunstroke is dependent on the temperature of the sun or temperature of the day. Okay. That is the dependency. So x is dependent on y. You call that x on y. What do you call that? X on y.
X on y.
X is dependent on y. Okay. The other way also it can be. Y is dependent on x means then you call y on x. Okay. So what is this regression? Forget the meaning of the word regression. Got nothing to do with what we are doing. Okay. Please understand. Again, I'm telling you that word regression analysis has got nothing to do with backsliding or going back to the average. Okay. What it means is that there are two variables. One is the dependent on the other one. Like number of fellows who die from sunstroke is dependent on the temperature of the thing. In Madras it is only 40 degrees. Very few people die. But Hyderabad it is 50 degrees. Many more people die. In Rajasthan it is 60 degrees. Thousands of more people die. Okay. The fellows who die is x variable. X is dependent on y. The temperature 60 degree or 50 degree or 40 degree. That is y variable. Okay. So y is independent variable. If you increase the independent variable, then the dependent variable will be changed. Okay. So if you decrease the independent variable, then the number of fellows who die also will change, come down. Okay. So you keep playing with y, which is an independent variable, because that is not dependent on anything. The dependent variable, the number of people who die will keep changing. Okay. So number of people who die is dependent on the temperature. That is why it is called dependent variable. You understood? So regression helps us to estimate the value of one variable, provided the value of the other variable is given. Okay. So you get an estimate. This is not a pakka value. It's only an estimate. The statistical method which helps us to estimate the unknown value of one variable from the known value of the related variable is called regression. Okay. Now you understand what is regression. Before that, they gave one stupid definition. That definition you will not understand. Forget that definition. This is the correct definition which I have highlighted it to. Statistical method which helps us to estimate the unknown value of a dependent variable. Okay. Unknown value is not known. How many people will die? We don't know. From the known value of the related variable. Oh, temperature is now 55 degrees. Oh, 55 degrees. Then so many people will die. You are estimating. Dependent variable you are estimating from independent variable. That is only called regression. Okay. Now in regression you have some equations. What are these equations? Regression equations are algebraic expressions of regression lines. Okay. What is a line? What is the equation for a line? Line equation will always come in this form. Okay. X equal to ay plus b. Either that way it will come, or usually it will come y is equal to ax plus b. Okay, you remember this only equation, algebraic equation. algebraic equation for line, linear equation. Okay, this is linear equation. Same thing only you have for regression. Okay, only thing is x is the dependent variable, y is the independent variable set. Okay, you understand? Or if it is y on x, y is the dependent variable and x is the independent variable. I told you, no, y on x means y is dependent on x. X on y means x is dependent on y. This is the dependent variable. This is the independent variable. Here y on x means this is the dependent variable. This is the independent variable. Okay, you should not get confused. You should be easily able to find what is the thing. Okay, if I say regression coefficient bxy, then you should say that x is dependent on y. Okay, x is dependent on y. Regression coefficient is always denoted by b. B only is denoting regression coefficient. Okay. Now, when we deal with the actual value of x and y variables, the two regression equations and their respective coefficients are written as follows. Now we are going to go to regression coefficient. What is this regression coefficient? I told you it will be a line equation. Okay. So this is the line equation. X minus x bar equal to b of xy. B of xy is a regression coefficient. Where b is a regression coefficient, where it says x is the dependent variable and y is the independent variable. X on y, b of x on y. So that means whenever regression equation is coming where x is dependent on y, okay, you will have x on the left hand side. Okay, you will have x minus x bar on the left hand side. Okay, this is dependent on y minus y bar. How it is dependent? It is equal to b of xy. Okay, that's all. If it is x will come left, y will come right side. Okay. Now the other equation is b of yx. Here x minus x bar, it will come like that. This side x, okay, and then equal to y minus y bar. This will come this side. Okay. This is y is dependent on x. Y on x. Okay. So two different equations. Two different line equations. Okay, both of them are coming there. Okay, very important. Now I have told you one thing. Let us look at the first type of equation only. Let us look at the first type of equation. X is the mean of the series. Very simple to find out. Y and x are on variables. You don't find the value of them. Just leave it like that. Okay, let's just leave y as y, leave x as x. Then from the set of data, you can find the mean x bar. Then from the set of y data, you can find the mean of y bar. Okay, once you get that, then all you have to do is find b of xy. What is b of xy? B of xy is regression coefficient of x on y. Okay, when you write bxy, you are writing x on y. That means x is the dependent variable and y is the independent variable. X is dependent on y. That's what it means. Okay. What is bx on y? That is equal to r. R is what? Correlation coefficient. Now only you are getting the relationship. Correlation coefficient with standard deviation of x divided by standard deviation of y. See again, x on y. X will be on top of y. Very simple to remember. Okay. X is on top of y. So sigma x is on top of sigma y. So x on y again. Okay. Now what is the expansion? This formula you need not use. You did not use this formula. Okay. It's only given there. What you need to remember is this only you need to remember. That is n into sigma xy minus sigma x sigma y by n sigma y squared minus sigma y the whole squared. Okay. That is what you need to remember. This is the formula for regression coefficient. Okay. Whenever x on y is coming, you will have y at the bottom because x is on y. Okay. Whenever you have the other one, b of y of x, you will have the opposite. This thing is wrong. Okay. N into sigma x squared minus sigma x the whole squared will be the denominator. Top will always be n into sigma xy minus sigma x into sigma y. Top will always, numerator will always be same. Denominator will always be changing. Okay. If it is x on y, okay, at the bottom you will have y. If it is y on x, at the bottom you will have x. Okay, that's all. Everywhere at the bottom you will have x. Okay, so this formula is wrong. Don't get confused. Okay, rest of the place in your examples they are using the right formula. This is all there is to regression equations. Two lines you have to draw. First line is x minus x bar equal to b of xy into y minus y bar. Okay, x on y. So this is x on y. X minus x bar will be on the left, y minus y bar on the right side. Same way, sigma n into sigma y squared minus y sigma y the whole squared will be on the bottom. Okay, okay, x will be on the top. Sigma x will be on the top. Sigma y will be on the bottom. Okay. That's all then. So two kinds of equations where whether you are getting x on y or getting y on x. Okay, x on y means on y will be at the bottom. Y on x means bottom will not be y, it will be x. Okay, that's all. Okay, now this is the direct formula. When are you using this? You are using this when the actual values of x and y variables, the two regression equations and the respective coefficients are written as follows. When you deal with the actual values, when you deal with the actual values of x and y variables, okay, then this formula is used. But you can simplify. As always, you can simplify. Instead of dealing with the actual values, take the deviations of x and y series from their respective means. That means you take x minus x bar and you take y minus y bar. Okay, dx and dy. Remember, if you take like this, then your formula becomes regression of x on y. Okay, x on y means b of x y, x on y. X side will come here, x minus x bar will come here, y side will go here, y minus y bar. You saw what you know that the other one I also want to remind you and show you. When b of y on x is given, okay, when b of y on x is given, y is on the left side, x is on the right side. Okay, so you remember how to write the equation. Y is on the left side, x is on the right side. So don't write all the things same time. Same thing, don't keep writing. Okay, these are simple things to remember. Otherwise, there is nothing complicated. It's also equal, as simple as what do you call your other analysis. But the three formulas you have to remember. Three types of formulas. Okay. One type of formula is n into sigma xy minus sigma x into sigma y by either n into sigma y squared minus sigma y the whole squared, or n into sigma x squared minus sigma x the whole squared, depending on x on y or x on or y on x. Y on x means bottom will be x squared like that will come. That's all.
Okay.
Okay, now second type of formula. Second type of formula, okay, where you are taking deviations. That means x equal to x minus x bar, y is equal to y minus y bar. Like that, if you are taking, okay, then the formula becomes very much more simple. Sigma xy by sigma y squared if x on y. Okay, see, b is x on y. Okay, so x on y. Therefore, sigma x on y. Therefore, this is common. This numerator will always remain the same. Denominator will become y squared. X is on y. If it is the other way around, sigma xy, if it is y on x, then equation will become y minus y bar equal to b of y on x into x minus x bar. Okay, y on x, x minus x bar. Therefore, y will be on top of x, sigma x squared you will get at the bottom. That's all. Instead of sigma y squared, you will get sigma x squared at the bottom. Now it will all look vague. When you start doing the sums, you will start, oh, this all, so he's telling this so many formulas for nothing. Okay. Same, regression equation of y on x. Regression equation of y on x. Okay, let us finish only the formulas. Example we'll do tomorrow or Thursday. Okay, now we saw this y minus y bar because y is here. Because y is here, left hand will be y minus y bar. X is here, right hand will become x minus x bar. Okay, x bar is a mean, y bar is a y mean, sigma y by x, because now y on x. Okay, so bottom will be x. So y is standing on x, we should think like that. So sigma x square. Okay, that's all there is to that formula. Okay, now there is a third type of formula. Okay, suppose your mean is not coming as an integer, then your calculation will be very difficult when you use the first method or second method. Okay, every time calculating x minus x bar, suppose x bar is coming like, x bar is 2.375. Then you're calculating 5 minus 2.375, 6 minus 2.3. That's all difficult. No, in that case, you should take assumed mean as before. When you take assumed mean, when the mean is not an integer, that's when you take assumed mean. Same here also. Here also, same. What does the formula become then? Okay, for y on b, y on x. Okay, this is y on x, b of y on x, y bar, y minus y bar, x minus x bar. That is, this equation is the same. But how you calculate the regression coefficient only is different. Okay, so b of y by x equal to, again numerator will be the same. Numerator will be the same. Okay. Sigma dx by dx dy minus sigma dx into sigma dy. Okay, this is numerator will be same. Bottom y on x means everything here will be related to x. X on y means everything here will be related to y. Everything here will be related to x. Okay, that's all. N into sigma dx squared minus sigma dx the whole squared. Okay, if it is y on x means x here. Okay, that means it is sitting on top of x. X on y means x is sitting on top of y. So bottom will be y. Okay, denominator will be everything related to y. Sigma n into sigma dy squared minus sigma dy the whole squared. Okay, that's all. What is dx? What is dy? It is all the same as in correlation coefficient. Okay, dy is equal to y minus b. Assume the mean for data set A. Assume the mean for data set B. You have to take. Okay, very similar to the previous one. Now let us do 2 minutes. We have. Let us do the properties of regression coefficient, and we can finish. Next class we can start the examples. Once you do examples, everything will be okay. Correlation coefficient is the geometric mean between the regression coefficients. Okay, this part. Geometric mean of A and B is what? Geometric mean of A and B is A into B. Geometric mean of A, B, C is what? A into B into C. A, B, C, D means A into B into C. Okay, like that, geometric correlation coefficient is geometric mean of the regression coefficient. That is B of xy into B of yx, the whole root. Okay, that's all. Plus or minus you have to keep. Very important. Plus or minus you have to keep. Don't forget that. Okay, so correlation coefficient is from the previous part we found out. How is correlation coefficient related to regression coefficient? Like this only it is related. Okay. Then one more. One of the regression coefficient is greater than unity. The other must be less than unity. Suppose b of xy is greater than 1. Then b of yx will be less than 1. Okay. Or b of yx is greater than 1. Then b of xy will be less than 1. Okay. That is the second property. Okay. Very easy to remember. Okay. Third property, after that we'll finish. Third property is telling both the regression coefficients are of the same sign. Okay. If you get b of xy as positive, suppose b of xy is positive, then b of yx will not be negative. Okay. This is a useful check. You are doing your problem and you are calculating b of xy, b of yx and all that. Suppose b of xy you get plus 2.5 or something. Then b of yx you are getting minus 1.23. That is means wrong. Your calculation is wrong. Okay. That's all. Okay. 6 o'clock reached. Very nice. I think some easy problems we did. Next class, when we start doing the problems, you will understand regression analysis. There is nothing regressive about regression analysis. All you are doing when you are doing regression analysis is one variable series is independent variable that is influencing another variable series, which is the dependent variable. That's all. Okay. This you use in economics, in finance, in research, in whenever you do any research, hypothesis formation, everywhere this regression analysis is very important. Only thing is there is nothing regressive about regression analysis, nothing backward or backsliding about it. It is all about relationship between one set of variables and another set of variables. As one influences another set of variables. That's all. Okay. Right. See you, man. Bye bye.
Okay. Bye. Have a nice day.
You have a nice day too.